We are looking at equations number 6 today. This is a review of linear graphs. The first thing you want to review is the types of slope. We have a positive slope, a line that rises from left to right. You can see the picture at the bottom. A negative slope, a line that rises from right to left, or a better way for me to say that is it starts at the left and it goes down. A zero slope is a horizontal line, and an undefined slope is a vertical line. Make sure that those are memorized and comfortable for you. Remember that slope is the rate of change, and we find slope by finding the rise over the run, or the change in y over the change in x. That simply means what happens to get from point to point on our line. We'll look at both of those things in the next few slides. So our first example is a drawn line. The line is there for us, and we need to find the y-intercept. This is a good time to remember that intercept for y means where does it cross the y-axis? It crosses the y-axis right at that point 1. So we would say that our y-intercept is 1. Our slope is found by figuring out how we get from one point to the next, our rise over our run. You can tell this is a positive slope because it starts low on the left and it rises up to the right. And to get from point to point, you're going to rise 2 and run 1. So your rise is 2 and your run is 1, which gives you a slope of 2. Now you write the equation. The equation always follows y equals mx plus b, where m is your slope, and we found that our slope was 2, and b is your y-intercept, and we found that it's 1. So y equals 2x plus 1. For this next one, you might challenge yourself to do this and then check the answer. So look at the picture, and you can see that it crosses the y-axis down at this spot, -3. So your y-intercept is -3. And your slope, again, you're looking at a positive slope starting in the left and going up to the right. And you count your rise over run, 1, 2, 3, 4, 5, 6, and 1. So you would say your rise is 6 and your run is 1. So your slope is 6. Write your equation, y equals mx plus b, and you would say 6x. Now notice your y-intercept is -3, so I could either write plus -3, or the more efficient way is to say 6x minus 3. Remember, plus and negative and minus are the same thing. Now you're looking at a negative slope. It starts high in the left and it goes down. You start with that y-intercept. So y-intercept, this time it crosses at 0. So it's a y-intercept of 0. Now you find the slope. How do you get from one point to the next? That rise over run, you're going down 1 and over 1. It's a negative slope. Your rise over your run, you're going down instead of up. So there's your -1 over 1. That's the same as saying -1. So now you write your equation, y equals mx plus b. This equation's a little bit different because you found your slope of -1, so you could say -1x. Your y-intercept is 0. However, we don't often say we have 0 of something. We would say that this is the same as saying y equals -1x, or even more efficiently, y equals -x. Because when we see -x, we know that really means -1x. Now for this one, we need to find the y-intercept. So our y-intercept is -1. We want to find the slope. Again, this is a negative slope. So we're going to notice that from one point to the next, our rise is going down 1 and to the right 2. So your rise over your run is -1 over 2. So your y equals mx plus b is y equals -1/2 x minus 1. In our next one, we have an interesting type of line. We have a vertical line. A vertical line, remember, has an undefined slope. So we have been asked to find the y-intercept. I want you to notice there is no y-intercept. It continues up and down indefinitely. So you would say none. The slope is undefined. All vertical lines have an undefined slope. So when we go to write the equation, that is not the method we can use. We have to look and see points on this graph. So we could take any points. I'm going to take the point 3, 3, and I'm going to take the point 3, 0. But you can take any point you like. Remember, it's x and then y. I will quickly notice now that every single point on this line, I'll switch colors, has an x value of 3. When we have a vertical line, it follows the pattern x equals whatever that x point is. So our vertical line, x equals 3 every single time. Our next line is a little bit different. This is something that does have a y-intercept. In fact, its y-intercept is right here at -4. So my y-intercept is there. My slope is 0. So a horizontal line to get from point to point is 0. So your slope is 0. So you actually can write the equation with our normal method, y equals 0x minus 4. However, 0 times anything is just 0. So this would go away and you're left with y equals -4. If you look at this, every single point on this line has a y value of -4. So you can go straight there if you remember that. Now the other thing you can be asked to do is graph. They give you the equation and they say to graph. We learned how to graph using a table or using the pattern, y equals mx plus b. I'm going to start with the pattern and notice that my y-intercept is -5. So that means I start here at that y-intercept of -5. I notice it's a positive slope and that slope is 3. So that tells me that my rise over my run is 3 over 1. So I'd go up 3 and over 1. And I want to make sure you know how to get points on the other side of the line is that I go down 3 and to the left 1. You can make as many points as you want, and then you would connect them and put arrows on the ends. Now I could also use a table, in which case I could pick values for my x's. And I'm going to say that I would pick the values of -2, -1, and 0. And I'll just do two or three of them to show you. So what I would do with those values is I would plug them in. 3 times the value I pick for x, which is -2, minus 5. So 3 times -2 would give me -6. Minus 5 would be -11. So my y value would be -11. And if I look here, I can see that on my graph, that is in fact what is going to happen is my -11. And I could do that again and say 3 times -1 minus 5. And that would be -3 minus 5 would be -8. And I can look at my graph and see that I have -8 right here. So another way to graph is to make a table. This next one, I'm going to show you the table and the graphing. This would be starting with our y-intercept of -3. Remember to be cautious about that sign. So you have your -3 for your y-intercept. And now your slope is -1/2. So you're going to rise. In this case, it's a negative, so you're going down 1 and over 2. The more points you make, the easier it is to connect without having a ruler. But if you have a ruler, you only need 3 points to make your line. To go to the other side, you have to reverse both. Go up 1 and to the left 2, up 1 and to the left 2. And then I'll connect my points. Now, if I were to ask you to make a table for that, I recommend you do things that are multiples of 2 because of the 2 in the denominator. So I would say that we would do -2, 0, and 2. And I'll just show how it works with -2. So I'd have -1/2 times my x value of -2/1 minus 3. -1/2 times -2/1, remember those are reciprocals, they turn out to be 1, so I would end up with 1 minus 3, which equals -2. So if I look, my value for -2 on my spot here does turn out to be -2. And you can do this for your other points as well. With our y equals 3x minus 5, I'm simply going to show the short way with the rule. I start at my y-intercept of -5, and I go up 3 and over 1, up 3 and over 1, and I can connect my points. With y equals 4, I want you to remember whether that is vertical or horizontal. If you can't remember, a table is a really good way to do this. Y has to be 4, so put in 4 for your y's. Put in any value for x. And then you will see right away what that looks like in your graph. So y equals 4. When you see something like x equals -3, you would say, oh, I'm going to put in -3. And I can put in any values for my y. So I'll just say 1, 2, and 3 again. So -3, 1, -3, 2, and -3, 3, all of those points. And you end up with your vertical line. So x equals -3. Notice I've labeled these lines because there's more than one line on the page. If there's only one line on the page, you can get away without labeling. Now, when we find the slope between points, there is that method of doing your formal y2 minus y1 over x2 minus x1. This is where we were told that it does not matter which order you go in. I often do my first point that I see as number 1 and my second point as number 2. So then I would replace my y2 and my y1 and my x2 and my x1. So watch how that works. My 12 is my y2 and my 0 is my y1. My 8 is my x2 and my 0 is my x1. So this is really 12 over 8, and I would reduce that and say both of those are divisible by 4, so that's really 3 over 2. Slope is the one time you can leave things improper. So this is a formula you want to have in your brain. It's really just rise over run. It's showing how you get from point to point. It's important that you have your y's on top because that's your rise, and your x's on the bottom because that's your run. So there's the solution to that. Notice this says 1.5. With slope, you are actually better off to leave this as 3 over 2. So I want to make sure you see that I would not mark you wrong with 1.5, but it'd be harder to graph because it's rise over run. Now we could find the slope that goes between these 2 points, and I'm going to ask you to pause the video and do it on your paper, and then check your answer when it shows up on the next screen. So remember our 2 points, and you'll now see here that you have your y2 minus y1 over x2 minus x1. Some kids, when they get here, might leave this as 3 over 1, but this would really just be a slope of 3. And that is the end of this review for now.